we were convinced that the current refinement model M2 actually has a life lock. And the way to prove it is by providing this witness system trace that actually show the divergence between two events, starting from over here, ILTL green, MLTL green. They simply just happen indefinitely. And we'll now try to see how we can fix this issue. And the idea would be we want to show that the color changes between the traffic light should be done in a disciplined way. And the way to do it, we want to do something with the enableness for these two events. And to do that, we got to introduce new variables and put these variables in the guards and also in the actions for the various events. So we can try to control the lights in a more disciplined way without any divergence. Let's see exactly how we do this. To regulate the traffic light changes, we would like to introduce two variables, or we call them flags. In this case, both variables are simply integer values, 0 or 1. However, the way we treat them is like a Boolean variables. So 0 for false and 1 for true. And you will see exactly how that goes. And we're going to use them to regulate the traffic light changes, since we got two traffic lights on the mainland side and on the island side. So that's why we got two variables for this purpose. Let's see the first one over here. So the first variable on the ML side, mainland side, is ML pass. Apparently, ML over here stands for mainland. Its value can either be 1 or it can be a value 0. Only these two possibilities. So that's why I call them a flag. And it will be 1 if, since the last time MLTL, the traffic light on the mainland side, has been turned green, at least one car exited from the mainland onto the bridge. So it will be 1. Otherwise, if since the last time the MLTL was actually turned green, but this so far there has been no car actually exited from the ML onto the bridge, in that case it will be 0. So what does it really mean when the line has been turned green but no car has really passed onto the bridge? So that simply means neither MLL1 nor MLL2 has actually occurred. I'll show you exactly what this means. Let's now see this right away. Right. Just let me remind you very quickly. So this is the divergence trace we just spoke about in the last part. I'm including over here just for our information. We'll see after we have introduced the two flags into the system how this divergence trace can be prevented. So that's something we'll go over as well. Now for now, let's now talk about the ML pass variable. Right. So we're gonna see ML pass, and ML and also ML pass over here. Right. 1, 2, and 3. Let's see exactly how this is gonna happen. Just recall the definition. ML pass will be equal to 0 if, since the last time the MLTL has been turned green, no car has exited from the ML onto the bridge. So what does that mean? Let's take a look. So what I want to do is I want to just highlight the part you will need to see. ML pass is assigned to 0 at the same time. So that means when MLTL green, which is supposed to turn the light on the mainland side to be green, in that case we're going to first assign this to be 0. So this is more like an otherwise part. So this means once the light has been turned green, no car has exited from the mainland onto the bridge just yet. Okay, let me just write this down right away so you can see how it corresponds to the definition. Since MLTL turned green, no car exited the mainland. Right? You can see the light has been turned green over here, which I wouldn't box. I need to save that for other explanation as well. Right? So far we're talking about when MLTL green occurs, meaning that the traffic light on the mainland side is going to be turned green. We initialize ML pass to be 0, meaning that since the last time the light has been turned green, no car has exited from mainland onto the bridge. And what about other cases? So let's take a look at MLL1 and MLL2. MLL1 over here and also MLL2. So these are the two occurrences of the events, right? You can see for both of them, we got ML pass is assigned to 1 as opposed to 0. ML pass is assigned to 1. So this really corresponds to the other part of the definition. Let me just refer you to that. If since the last time MLTL was turned into green, at least one car exited from the mainland onto the bridge, meaning that either a car can exit from the mainland by the occurrence of MLL1 or by the occurrence of MLL2. Either one is okay. So that means if either one actually happens, you should really assign this to be 1. Okay. So for these two, I'm just going to make some explanation over here. Since ML TL turned green, some car, at least one, some car exited the mainland. Right? It's very important for you just to see these three actions over here actually correspond to exactly what we just said about the definition. Okay, let me just highlight once more. So no car versus some car. Okay, and I'm just talking about this part of the this definition over here for ML pass, which has two parts. Symmetrically, we have another variable on the island side. Let's now go over the definition again. Very similar. IL pass also can be either of value 1 or it can be of value 0. Okay, the value will be 1 for IL pass if, since the last time ILTL traffic lights was turned green, at least one car, some car has exited from the island side onto the bridge. If that's the case, the value will be 1. What should be the events occurring for some car actually exiting from the island? It will be IL out 1 and also IL out 2. The two split events that we spoke about earlier. Otherwise, if since the last time ILTL was turned green and no car has exited from the island, in that case, this IL pass should be 0. And let's see the similar encoding of this general definition about IL pass in the event. Let's take a look. Very similar to how we explain it for ML pass. Let's now talk about this one over here. So we talk about ILTL green. Right, so this is the events that's supposed to represent when the green lights of the traffic light on the island side has been turned on, right? Has been turned green. You can see here when the traffic light was first turned green, no car has exited from the island. In that case, this should be initialized to be 0. Okay. So what I want to do is I want to do a similar explanation over here just for completeness. Since IL TL turned green, no car exited island. You can see that over here when ILTL is actually assigned becomes green. In that case, we first initialize IL pass to be 0, meaning that after we have turned the light to be green, no car has exited from the island just yet, but it will be more car actually exiting from the island if either ILL1 occur or ILL2 occur. We'll talk about it in just a moment. Right, so let me say no car over here. And when does IL pass become 1? Is when either IL out 1 occur or IL 2 occurs, either of them. And let's see exactly. So you can see here IL pass is assigned to 1 over here, and also IL pass becomes 1, as opposed to the variable being initialized when the ILTL was first turned green, right? So you can see these two really corresponds to the definition of the IL pass. Right? Let me just show you again. If you go back to the slides, you can see IL pass is 1 if, since the ILTL was last turned green, at least one car exited from the IL onto the bridge. And at least one car, every time if there's a car exiting from the island, it will be represented by the occurrence of either IL out 1 or IL out 2. Right? Let's write it down over here. It's really important to get the definition straight first, and then I'll show you more insights into the events design. Since ILTL turned green, some car, at least one, exited the island. Right? So it's important to know it's actually some car over here, as opposed to no car. Let me recap what we have said so far. We talked about how these two variables, ML pass and also IL pass, should be manipulated. For the case of ML pass, when the MLTL is first turned green, we're going to reassign ML pass into 0. And then for any new car exiting the mainland, which can be either ML out 1 occurring or ML out 2 occurring, in that case, we're going to assign ML pass into 1. According to the definition. Symmetrically, when the very first time we turn the ILTL to be green, we're going to reinitialize IL pass to be 0. And when do we let it become 1 again? It's either by ILR1 occurring or ILR2 occurring, in which case we're going to reassign IL pass to be 1. Let's now go over some tricks to see why divergence is no longer possible given we have already introduced ML pass and also IL pass. And I'm going to go over this longer trace compared with the divergence trace before. But just by going over this, you will be able to see why the earlier divergent trace is no longer possible. So once we have gone through this trace over here, it will be left as an exercise for you to really see why the original divergence trace is no longer possible. I'll definitely mention some insights you will need to know in order to do that exercise. Okay, make a note and do that exercise later. Let's now try to go over this trace over here, starting from init. Remember, initially, both traffic lights are actually red. In that case, the traffic light has not been turned into green, so ML pass will not yet to be set to be 0. So that's why both of them will just be 1 over here. So that's the rationale for why the initial value for ML pass and IL pass should be 1 for both. Let me just write it down over here. The reason that both of these should be 1 is actually because ML, TL, and also IL, TL, both red in the beginning. And let's try to go over the different events. Let's say we want to turn the traffic lights on the mainland side to be green. And we're going to execute this, right? You can definitely check to see the GAR IL pass is actually equal to 1. And for now, I'm going to ignore the manipulation for A, B, and C, right? That's something we did earlier, but let's now focus more on ML pass and IL pass. Specifically, we want to see how the events are going to be enabled and disabled to really prevent divergence. That's really the focus point to look at. So when we do, let's say, ML TL green, when the event occurs, we're going to set, of course, the traffic light to be green and ML pass is to be 0. It's very important to see that. And we're going to put this as 0 over here, ML pass. IL pass doesn't change, so remain to be 1. And it's very important to see something over here. As soon as the ML TL has been turned into green, so that means ML pass is assigned, it has become 0. This will effectively disable the occurrence of ILTL green, just the other new events. Remember what we said before, divergence happens when these two events interleave with each other indefinitely. But now ML pass would become 0, which effectively disable the guard of ILTL green. So this will disallow the consecutive occurrences of MLTL green followed by ILTL green. It's a very important insight to actually see. Let me write it down over here right away. You can think about this ML pass over here becoming 0 is really effectively disable the occurrence of ILTL green immediately following. Right? Disabled. This one really disable the occurrence of ILTL green. We will see some symmetric disableness as well a little bit later. Okay, so that's what I want to say for now. And let's now try to see from another angle. This ML pass becoming 0 will disable the other new events from occurring right away. But what about the other old events? We should really allow the old event to really occur so we can avoid divergence. The other old events that will be applicable will be ML out, either version 1 or version 2. And you can see both of them have their guards MLTL to be equal to green. So that's indeed what's really made possible by MLTL green occurring. Right? That's also important to remind you about that insight. MLTL green over here, this one over here really enabled ML out 1 and also ML out 2 here as well. Right? So this will be enabled. There are many details over here that you should really try to put them together and study carefully, but I'm just going to mention them to you quickly. You can definitely rewind a video and think about it. And let's now continue with the trace. Given that the MLTL green is going to enable the MLL1, right? For now, I'm just going to ignore the manipulation for the variables A, B, and C. So those are the manipulation we have done many exercises about already. So for now, let's focus more on the ML pass and IL pass. So ML out 1 will be enabled, and also ML out 2 will be enabled as well. So that's why you saw these two entries over here. Right? Let's now fill in exactly the values. For ML out 1 and ML out 2, both of them are going to maintain the value of the ML pass to be 1. So these two will just be 1. And as you can see, they didn't really mention about IL pass, meaning that it's simply just going to remain the same value, which would be just 1. And similarly, for ILN events, remember for ILN and also symmetrically MLN. So these are the two events that we set in the very beginning of the refinement model M2, that these two concrete events, which are inherited from M1, they simply don't really get affected by the traffic light. So that's why they always remain the same actions and guards, in which case they are not going to affect the value for ML pass or IL pass. So they simply remain just the same value. 1, 1, and 1, 1. Up to now, we actually got inits, MLTL green, ML1, 2 times, and also ILN. So this essentially corresponds to what we had before until over here. Right? So now we can now talk about ILTL green, which will be important. And let me also try to just highlight what we have got so far. MLTL green, you should really watch out for how that one enabled ML1 and ILN. And also ILTL green over here, we're going to see how that one there is going to disallow another immediate occurrence of MLTL green. We're going to see that in just a moment. Okay. So what's going to happen for ILTL green? The effects will be kind of symmetric. Let's talk about it. If you look at ILTL green over here, at the moment ML pass is simply just 1. As you can see, ML pass is actually 1. So that means it is enabled. So we can actually turn the island light to be green. In that case, we're actually going to do it, and by doing that, we're going to assign IL pass to be 0, meaning that after the green light has been turned on, no car has just been passed yet, as we said in the definition. And this one over here is effectively going to disable the MLTL green from following. You can see IL pass must be 1, but that's just been assigned, just become 0 over here. Okay, it's kind of symmetric. Right, so for this one over here, let me just do a similar annotation over here. So IL pass becoming 0 effectively is going to disable this part over here. Right, this part over here, IL pass equals 1. Right, you can see that one there is actually going to disable this particular event from following. So we don't really have divergence, meaning that after ILTL green, we cannot have MLTL green immediately following, which is really the start of the divergence pattern. We cannot. So this will be disabled. Think about this, the disabling is really from each other. Whenever this occurs, it's going to disable the other one. And whenever this occurs, its action is also going to disable the occurrence of the other one. It's really meant to really prevent the divergence that we saw in this example trace over here. And more to say, the fact that the ILTL green is going to turn the ILTL to be green over here, the traffic light, is actually going to enable the relevant old events to really happen. So the way we break the divergence is by saying after the occurrence of the new events, there's got to be some old events happening afterwards. So we don't really have the new events indefinitely happening. Let me write it down over here, and then I'll make some annotation. To break the divergence pattern, after each new events occurring, some old events must occur. Right, that's really the principle over here. To break the divergence pattern after each new events. For example, let's say MLTL green. After that, in that case, it's going to enable the MLR1, MLR2. At the same time, it's going to disable ILTL green. Symmetrically, after the occurrence of ILTL green, it is actually going to enable, as we'll see, IL1 and IL2. And at the same time, it's going to disable the other new events, which is MLTL green. Right? That's really important for you to see. And you may just want to rewind the video if you miss any points. But anyway, I think I said everything that will be necessary. Some old events occur. Right? Good. And let me make that annotation here. So the fact that we actually try to let ILTL become green, this one over here really enabled either this relevant old events or this relevant old events. Very similar to how this one over here enabled these two. Okay, let's make that annotation. And then we can go back to the tracing table. And I'll try to be as careful as possible over here, possibly. Okay, so this will be one enabling, and this one over here will just be another enabling. Okay, that's kind of the best I can do. So this will be enable. Right, so hopefully it's not that messy, but that's why it's the reason I'm trying to draw so many annotations, because there's so many design rationale you have to understand. Right, you just want to go over one by one carefully, and feel free to actually maybe wipe out all the annotations and then try to get a clean one from your slides, and then try to annotate yourself to see all the correspondence. Right, what's going to happen after ILTL green over here? Right, is going to let IL pass reset to be 0. So what's going to happen is he's going to reset this one to be 0, whereas ML pass is not really mentioned, so it remains to be 1 over here. What about the subsequent occurrences of IL out 1, IL out 2? IL out 1, IL out 2 is just going to let IL pass re-become 1, because now some car actually has exited from the island after the green lights. So what's going to happen is it's going to turn that into 1 over here. This one remain to be 1. And similarly, this also is going to be 1 over here. Right? You can see here, just going to let it become 1 over here. What about MLN? It's not going to affect any of the variables that we introduced in this refinement. So they simply just remain to be 1, 1. 1, 1, 1, and 1. Alrighty, so that's about the tracing I would like to do together with you. And you should really understand why what used to be possible for the divergence pattern before we introduce ML pass and IL pass is no longer valid. Because now, after we have done some manipulation for these two flags or these two variables, we are able to prevent this kind of a divergence pattern from happening. And this is the trace that we actually went together with you. The next step in the next part will be to talk about how we can make use of the ML pass and IL pass as the kind of like a variance for us to measure about the occurrences for the new events, so that we can prove the system is formally divergence free of life lock. That's something we'll do to the next part. But before that, I would suggest try to look at all the correspondences in terms of the event design before you actually move on, so that you actually can gain the most out of it.